Getting series with definite integrals. The Riemann sum of a function is related to the definite integral as follows. The definite integral on the interval from a to b gives us the signed area under the curve. In the limit definition, it is the sum of an infinite number of tiny rectangles whose area we're adding or summing up. This is the definition of the Riemann integral, the definite integral, and this will become important later. Life is an exercise in evaluating our limits. Find the exact value of this limit. Pause the video now if you'd like to figure it out. We begin by looking at this series and writing it out in a compact notation. So the sum of 1 over radical n plus 1 plus 1 over radical n plus 2 all the way up to 1 over radical n plus n can be given by the series starting from k equals 1 all the way up to n of 1 over radical n plus k. Now what we're going to do is we're going to work on this factor of 1 over radical n plus k. So we factor a 1 over radical n out of that expression. And then what we're going to do is we're going to factor another radical n out of that factor of radical n plus k. And the reason that we're going to do this is because we would like the factor on the outside to now be 1 over n. And 1 over radical n times 1 over radical n is, in fact, 1 over n. So our series becomes, from k equals 1 to n, 1 over radical 1 plus k over n times 1 over n. Now the variable we're summing up here is k, so n is just a fixed number, and later we'll take the limit as n goes to infinity. Now what I want you to do is I want you to imagine the function f of x is equal to 1 over radical 1 plus x. So you can see where I'm going with this in the relationship to my series. Next, I want you to consider that x lives on the interval from 0 to 1, and I'll justify this in a minute. On this interval, f of x is greater than 0. Another way of saying that is it is positive. So on the interval from a to b, delta x can be given by b minus a divided by n. And on the interval I've chosen here, that'll give us a delta x of 1 over n, something that we have in our series. So delta x is 1 over n, and we're going to let x sub k be the value of k over n, where k is going to run between 1 and n, as in our series. And that justifies why x is a value between 0 and 1. Because we're going to take the limit as n goes to infinity, the series, starting from k equals 1 to n, of f of x sub k times delta x, in the limit as n goes to infinity, is the definition of our Riemann definite integral on this interval from 0 to 1. So this is going to equal the integral from 0 to 1 of f of x dx, which is the integral from 0 to 1 of 1 over radical 1 plus x dx. Now this integral isn't terribly difficult to do. We'll do it by u substitution by letting u equal 1 plus x, and therefore du is equal to dx. This will slightly change our limits of integration from 0 to 1 to 1 to 2. Rewriting our integral from 1 to 2, this is the integral of u to the negative 1/2 power du. which is going to equal 2 times u to the 1/2 power from 1 to 2, or 2 times the square root of u from 1 to 2, and evaluated, that gives us 2 times square root of 2 minus 1. So there you have it. That is the value of our series when evaluated at the n going to infinity limit, and we used the definition of the Riemann integral, the Riemann definite integral, to do the work for us. I hope you liked this video. Please hit that like, subscribe, and notification bell for more videos, and stay tuned for the next one. Thanks for watching.